This lesson covers surface area of pyramids and cones. Turn to page 7 of your Chapter 12 packet. We're going to start by filling in the definitions for cones. So notice that you see a cone over on the left-hand side of the paper. There are some basic pieces that we need to talk about. A cone by definition has a circular base with a vertex that is not in the same plane as the base. So what you see here is a vertex up at the very top. You have a height that is the altitude, and it is perpendicular to the radius or the diameter of the base, which is a circle. Additionally, you have an extra kind of height that's listed on the side, and this is called the slant height. In the second picture, you can see they've designated the slant height with a value of L, and that is needed for one of these formulas. The lateral area, meaning only the sides of the cone, not the base itself, is calculated by pi RL, which is radius times the slant height. The slant height is listed here. So you're not going to be using h, just the slant height. And the slant height in this case is the hypotenuse of a right angle that's made from the height and the radius, or a hypotenuse of a right triangle. The surface area is entirely the lateral area plus the base, which is a circle, which is pi r squared. So surface area is pi r squared plus pi RL. So we have another height. So we've got a couple heights that we've been working with. We have the height of the prism, the pyramid, which we're going to do shortly, the cylinder, and the cone. We also have the height of the base of a prism or pyramid if you have to calculate it. And now we have this new height called the slant height, which is the height along a lateral face of either a pyramid or a cone. We'll come back and fill in the definitions for pyramid. Once again, the slant height forms a right triangle with the radius of the circle and the height of the cone. It's the hypotenuse. And you use Pythagorean theorem to find it. 2 practice problems. Number 1, find the lateral area and surface area of the following cones. So you have 2 things that you'll need to know. You're going to need to know the radius and the slant height. And this particular problem, they give you both of those. The radius is 16 and the slant height is 24. Calculating the lateral area is pi RL, so pi times 16 times 24 gives you 348 feet squared. 384 pi, sorry. The surface area includes the lateral area, but you're also working with the base, which is a circle. So we use the radius over here, which is the 16 squared. So from the lateral area, we get 384 pi, and from the circle, we get 256 pi, for a total of 640 pi feet squared. Number 2, in this particular cone, the base is still the circle with a radius of 6, but this time they give you the regular height, which is 8. That is not used to calculate the lateral area or the surface area. We need the slant height. This particular right triangle is a Pythagorean triple, which means the hypotenuse is 10, and that is your slant height. So your radius is 6, and your slant height is 10. Lateral area, pi RL, pi times 6 times 10 is 60 pi feet squared. Surface area, the pi RL is the 60 pi plus the pi r squared, filling in r with 6. So we have 60 pi plus 36 pi, which is 96 pi feet squared. Go back to page 7. We're going to fill in the words and information for the pyramid. So we have a pyramid here. By definition, a pyramid is a polyhedron with a polygon base that names the particular type of pyramid. So for example, in this picture, all 4 sides of the base are congruent, so this is known as a square pyramid. The lateral faces are always triangles that have a common vertex up at the very top. You'll notice you have a height, which is from the vertex down to the base in the center of the base. You also have a slant height, which is going to be the height of one of these sides or one of these faces. Another piece of information that you're going to want to add into your picture is what's called a lateral edge, and it goes from the vertex to a vertex of the base. In terms of formulas, we have two of them. So in this particular picture, you'll see where you have lateral area, which is faces only, and that's 1/2 LP. We've seen P before being perimeter of the base, and L we know to be slant height. The surface area is the lateral area plus the base, and the base you'll calculate depending upon whether it's a square or a rectangle or a hexagon, just based on those formulas that you already know. Pyramids can have any base. For most of our problems, we're only going to calculate surface area and with bases that are equilateral. So the ones that don't have equal sides on the bottom are a little bit more complicated to calculate because the faces end up being different sizes. Number 3, find the lateral area and surface area of the pyramids. We're going to assume for these particular problems for practice that all of the bases are going to be regular polygons. So before you start, you should determine what type of base you have. In number 3, you can see that we're going to have all 4 sides congruent, so we have a square base, which is going to be a square pyramid. The slant height is given, which is an 18. The perimeter is the perimeter of the base, and you have 4 sides that are all 16, so the perimeter is 64. And the big B is the area of the base, which is 16 times 16, which is 256. Lateral area is going to be 1/2 LP, which is 1/2 times 18 times 64, or 576 meters squared. Surface area includes the lateral area plus the base, so you're taking the 576 plus your 256 for a total of 832 meters squared. Number 4, visually it does not look like it, but we're going to assume that all of the sides of the base are congruent, which would make this an equilateral triangle for the base. So slant height is already given here. You have 11. We're assuming that all 3 sides of the base are 13, so 13 times 3, giving you a 39. And the base itself, you're going to have to do some calculations here because it's considered an equilateral triangle. So we're going to work with a 1/2. And the base of one of these is 13, but remember the height or the altitude of this base triangle, which if I trace it, you can see it in red. You would need to draw in the altitude for that. So the altitude is going to be half of one of the bases, which is going to be half of 13, or 6.5, times the square root of 3. And since this number gets a little complicated, we're going to go ahead and use a decimal for it, 73.18. So we have lateral area is 1/2 LP, which is 1/2 times 11 times 39, which is 214.5 centimeters squared. And then the lateral area plus the area of the base, which gives you 287.68 centimeters squared. Number 5, this particular object has a square on the bottom, so that is a square pyramid. Now this time you'll notice they're only giving you the height of this particular pyramid, and we need slant heights. So you're going to add in the slant height. The slant height, and I'm going to show you where this goes, is going to be perpendicular. It's going to be perpendicular to both the height and the pyramid of the base. So what we're going to do here is take the height piece, and we're going to connect it over to the 10, and then we're going to connect up for the slant height, and you can see we have a right triangle. Now the big question is, if this side is 7, what is the other leg of this triangle? The height comes down right into the center of this particular square. So if we look at the 10 here, and we also have a distance of 10 along the width and the length, then this point runs halfway. So this length is going to be a length of 5. You're going to use Pythagorean theorem to calculate your slant height, and you can see I've done a new picture over here. So you're working with 7 squared plus 5 squared. You have 74. This does not come out as a nice radical, so we're going to go ahead and do a decimal equivalent for this later on. So we're going to use square root of 74 at least now, but later on we'll change it to a decimal. So we have our slant height. Fix that. Square root of 74. And we have a perimeter. There we go. Our perimeter is going to be 40 because you have 4 sides with all sides of 10. And then the area of the base is going to be 100. So we have 1/2 LP. So we have 1/2 times the square root of 74 times 40. And I would go ahead and convert that over to a decimal. So we have 172.05 feet squared. Surface area, 172.05 from our lateral area plus the base of 100 gives us 272.06 feet squared. Number 6, the base is a hexagon. So we're going to have to calculate the area of the hexagon, but at least they do give you the slant height already. So you have a slant height of 14. The perimeter of the base, each side is 9 because it is a regular hexagon. So we have 9 times 6, which is 54. So remember, with the hexagon, you have a hexagon created out of 6 equilateral triangles. So I'm going to figure out the area of one of those and then times by 6. So the area of one of those equilateral triangles along the base would be 1/2 with a base of 9, and the height would be half of the 9 times square root of 3. So we have 4.5 square root 3, which gives me approximately 210.44. So use your values here. 1/2 times 14 and 54, which are your slant height and your perimeter, for a lateral area of 378 feet squared. And then we're adding that to the base to get the surface area, 588.44 feet squared. For this next section, I want you to practice these 3 problems. Find the area of this particular square pyramid. The second picture is a square pyramid as well. And then I'd like you to find the lateral area of this particular cone. Pause the video, work out the problems, and when you finish, come back and check the answers. First one is 48 meters squared. Your second one is 928.4 centimeters squared. And your third one, it's 50 pi meters squared, or you can also write 157.08 meters squared. This concludes the lesson for surface area of pyramids and cones.